a 52-card deck. 3 cards are drawn at random without replacement. Calculate the probability that the 3 cards form a straight.
To solve card-related probability problems, it is essential to first visualize the composition of a standard 52-card deck. The deck is divided into 4 distinct suits: clubs, hearts, diamonds, and spades. Each of these suits contains 13 ranks spanning from ace, 2, and 3 up through jack, queen, and king. A clear understanding of this structure is the foundation for mastering card-based probability.
Every card in the deck has 2 primary characteristics: its rank and its suit. Rank. This identifies the card's value or face. This is the range that runs from ace, 2, 3, and so on up to the face cards jack, queen, and king. Suit. This identifies the card's symbolic category. This is one of the 4 symbols: clubs, diamonds, hearts, or spades. Since we are drawing 3 cards from a deck of 52, our aim is for them to form a straight, that is, cards that are consecutive in rank no matter their suit. Let's first look at some examples to understand what a straight truly means. Here are a few examples of 3-card straights. One possible straight is ace 2, 3. Shown below are some of the different variations such straights can take. We know that probability is determined by dividing the number of favorable outcomes by the total number of possible outcomes.
The total possible outcomes are given by 52C3 as we are selecting any 3 cards at random from a deck of 52 cards.
Let us understand what this formula does. It takes all 52 cards as input and generates an exhaustive collection of every possible group of 3 cards that can be formed from the deck. Thus, when we input these 52 cards into the formula, it outputs every possible group of 3 cards that can be formed from the deck. Since we are forming a 3-card straight, let us imagine placing the first card in the first slot, the second card in the second slot, and the third card in the third slot. There are a total of 12 possible consecutive 3-card rank combinations that can form a straight. These begin with ace, 2, 3, followed by 2, 3, 4, then 3, 4, 5, and so on, continuing up to jack, queen, king, and finally queen, king, ace. Thus, there are 12 distinct rank sequences that make up a 3-card straight. Okay. Now let us determine how many different types of 3-card straights can be formed from the ace, 2, and 3 combinations. There are 4 different types of aces, each of which can be placed in the first slot as we will illustrate visually here. Now, we move on to fill the second slot with the different 2s. There are 4 2s and each can be paired with every ace placed in the first slot. Thus, whenever there is an ace of hearts in the first slot, there are 4 different 2s that can occupy the second slot. The same situation applies to every other ace placed in the first slot. Each ace can be paired with 4 different 2s in the second slot.
Hence, there are a total of 4 into 4 possible combinations for choosing the first ace and the second two.
Similarly, when the ace of clubs is placed in the first slot, there are the same 4 possible twos for the second slot. And the same holds true for the ace of diamonds and the ace of...
Thus, there are total of 4 into 4 possibilities for first card, ace, and second card, any two. Now, let us fill the third slot with the threes. Since there are 4 different threes, the third slot can be filled in 4 possible ways. And this applies to every combination of ace and 2 in the first and second slots. Here, we will only display one possible arrangement, though the same logic holds for all other combinations. Thus, there are 4 possible aces for the first slot, and for each ace, there are 4 possible twos for the second slot. Furthermore, for each such combination, there are 4 possible threes for the third slot. Hence, this creates a total of 4 into 4 into 4 possible combinations. Thus, there are 64 distinct variations of outcomes that can be formed from the first straight, ace, 2, and 3.
There are a total of 12 possible consecutive 3-card rank combinations that can form a straight. These begin with ace, 2, 3, followed by 2, 3, 4, then 3, 4, 5, and so on, continuing up to Jack, Queen, King, and finally Queen, King, Ace. Thus, there are 12 distinct rank sequences that make up a 3-card straight.
Since one possible straight combination, ace, 2, 3, can occur in 64 different ways, and there are 12 possible straight sequences in total, the overall number of ways to form a 3-card straight is 64 multiplied by 12 equals 768. Thus, the probability of drawing a 3-card straight hand from a standard deck of 52 cards is approximately 3.47%.